Hi and welcome to this Leaving Cert Higher Level Financial Maths video. So in this video we're going to look at the time value of money, we're going to explore interest, we're going to learn how to calculate both the future value and the present value. The time value of money. So is €10 now the same thing as €10 next year? So ignoring inflation for any business students who are saying, of course not, we have inflation. But is €10 now, so if there was no inflation, is €10 now the same as €10 next year? So the answer is no, because if you had €10 now, you could invest it and earn interest. So this means that €10 will be worth more this time next year. So this is called the time value as money. As time passes, money becomes more valuable. So if I said to you, can I borrow €10 and I'll give it back to you next year? You would probably say, yeah, but you'll need to pay me back more than the €10 you borrowed. And that's to account for the fact that you didn't have the money for a year. That money could have been doing work for you. And when I say work for you, I mean earning interest. So if I'm going to get 1,000 bonus if I stay with the company for 3 years, what is that worth now? So I'm trying to understand if I have a future value, so a value of something in the future, how much is that worth to me now? So if you say I'm going to get €1,000, that sounds great, but if it's in 3 years, but like, okay, so what would that be worth now? What would somebody have to offer me now to match that? So if they offered me 1,000, yeah, 1,000 now is worth a lot more than 1,000 in 3 years. But if somebody offered me 800, would that be enough? So it's important for us to try and make the connection between the value of money in the future and the value of money now. And that's known as the future value, so the value in the future, and present value, so our value right now. So we have some formula here in our log tables. Some students don't use this at junior cert, some do, some see it in business, but this is on page 30. The heading is financial mathematics, so it's quite easy to find using your contents, so page 30, and we're going to see some formula here. The first formula we're going to look at is the compound interest formula. So we have f is equal to p bracket 1 plus I to the power of t. It tells us f is the final value and p is the principal. I tend to talk about f and p as our future value. So they've said final or future. And p, that principal, I refer to as our present value. It makes it a lot easier as we're working through the questions. Just to be aware, there's a little piece up the top here that says, in all the following, t is the time in years, and I is the annual rate of interest, depreciation, or growth expressed as a decimal. So, for example, they said 0.08 would be 8%. And that is so important. But then there's also an asterisk beside that, and at the bottom of the page it gives us a step more, and it says the formula also apply when compounding at equal intervals other than years. In such case, t is measured in the relative time periods of time, and I is a period rate. So what they're saying there is, if I, the interest rate, is annual or yearly, then t must be years. But if I is monthly, then t must be in months. So these formula will also work there. Be aware of that idea of using the decimal rather than the percentage. So example 1, we're going to look at future value. It says find the future value of 5,000 invested at 4% AER. I'll talk about the annual effective rate in a few slides. And it's compounded annually for 6 years. Find also the interest earned over that period. So the first thing we're going to do is we're going to write our formula. So the future value is equal to the present value times 1 plus I to the power of t. I'm looking for the future value. My current present value is 5,000. And my I is 4%, but we don't use percentages, we use decimals, so 0.04, and the time period is 6 months. So F is equal to 5,000 times 1 plus 0.04 to the power of 6. And that can go straight into your calculator. Remember that this is money, so 2 decimal places unless you're told otherwise. So 0.59, so that's 60. Okay, so that's my find the future value. And then the second part was find the interest. So the interest can be easily calculated by getting the difference between what my investment will be worth in the future and take away then what is it currently worth. So your previous answer minus 5 is 1,000. That gives us the interest, and I should use my euro symbol here, 1,326 euro and 60 cents. So very straightforward. This kind of question was something we saw at Junior Cert. So example 2, an investment bond offers a return of 15% if invested for 4 years. Calculate the annual equivalent rate or effective rate for this bond, correct 2 decimal places. Okay, so we're going to start looking about this idea of compounding at different rates. This bond gives an overall return of 15% over 4 years. So you'd say, well, actually, if I take 15 and divide it by 4, I get about 3.75%. Is that not what percentage it gets each year? And unfortunately, because interest compounds, so you get interest on interest, it's not as straightforward as that. So what I'll say is, let's invest a bond, I don't know, a principal, P, and we're going to invest it at some rate, I, for 4 years. That is currently the same as getting the same thing invested for one period of time at 15%. Okay, so that is the same thing. Here I have annual. Here it's over 4 years. And they should be equivalent. So this P invested at 15% over the course of the whole life of the bond, 4 years, should be the same as P invested at some interest rate I for 4 years. Notice that actually it doesn't matter about the P's because the P's cancel. So we get this little equivalence that is 1 plus I to the power of 4 is equal to 1.15. And I want to solve for I, which is the annual equivalent rate. So first thing I'm going to do is I'm going to get the fourth root of 1.15, and then I'm going to take a 1 from both sides. Now, I am not a fan of decimal, so I try to leave it until the very last step to put everything into the calculator so I don't have to mess around with the decimal. I find personally that it's very difficult to get this written down correctly, and things often go wrong. So in your calculator, find that fourth root, put it in, and then subtraction 1 is not under that root. So we get I as 0.035558. They want it correct to 2 decimal places. However, you will be expected to put this into percentage. So this would be 3.56%. And that's our final answer. So remember that I is given back in decimals, but we will give our answers to any rates as percentages. So take a look at interest rates. So we're going to look at a scenario and imagine that interest rates are compounded annually, so every year. So you're going to save money all year long, right? And you have 500 euro in your bank account at the start of December. Then you withdraw the money to buy Christmas presents. Then at the end of the year, you have 0 in your bank account, so you get no interest. And like, is that fair? And I don't think it is anyway, because you've been saving all year and you should get the interest on that. So in banking situations, interest compounding annually is very rare. Instead, the interest is compounded monthly, weekly, daily, or even hourly in some situations. So depending on like how much money, the bigger the sum of money, the more often you would like to calculate interest. Annual interest rates might apply to saving schemes where money is put in and it stays there, nothing is added and nothing is taken away. So actually monthly wouldn't make any difference here. For us, we really only need to worry about monthly. However, we have seen weekly appear on mock papers. The method is exactly the same. You just need to know how many weeks are in a year, 52, instead of monthly that we know there's 12 months in a year. But you could even work it daily. The same method applies. So for transparency and comparison purposes, the banks don't tell you the rate of monthly, weekly, or daily interest. Instead, they tell you the equivalent rate that you would get if the same amount was invested annually. We see two types of interest rates when we're looking at any of our financial maths questions, and we have AEOR and APOR. Now, AEOR stands for annual equivalent rate or effective rate. I tend to use effective rate. And APOR stands for annual percentage rate. They effectively mean the same thing. We see AUR when we're talking about savings, and we see APOR when we're talking about loans. That's really the only difference. They both are an annual representation of a more frequently compounding rate. So what it allows you to do, if we take loans for example, is to compare different loans or loans that may be compounding in a different way. So some the interest might be monthly and some the interest might be weekly, and allow you to compare it kind of like for like. It is a legal obligation with loans for you to be given an APR. So I have some screenshots here. Now these are a couple of years old, but I do like to put these in. You'll notice down here at the bottom of the screen, it gives us this representative APR. So basically it's not annually compounding, it's compounding a lot quicker. This is a payday loan company, so very short-term loans, very high interest rates. And you can see that it has a 1,270% APR. Now, we don't see anything at this level now. I think this screenshot came from about 2010-ish. So it's a it's a good few years old. We don't see it this high anymore. But just so you really truly get the impact of what this means, if you borrowed If you borrowed €100 now, in a year you'd pay back that €100 plus €1,270. So in total you'll return 1,370. Like, that is crazy. And that's what that rate means. Those payday loans, and you might say, but then why do people take them? They try not to focus in on the APRs when they sell the loans, and instead, if you want to borrow it for a month, it'll cost you so much. So obviously it's a lot less, but these are really focusing in on people who have bad credit. So that means they may not easily get a loan from a bank, and they may not have access to like a credit card, and so on. So a second one here, which is even worse. The typical APR is 2,356%. So that, again, bear in mind, if you borrowed €100 from them now, in a year you would end up paying back the 100 plus €2,356. So that is a total you'd have to pay back of 2,456. And that's so important to understand that APR. And I suppose if that wasn't a legal requirement to give the APR in any kind of lending, that could be given as like, 40% interest or 20% interest. And you might say, oh, that seems okay. But this is really to impact. Now, unfortunately, people still still use these payday companies. But like I said, if you look at them now, the interest rates, they're still very high, but they're nowhere near this kind of level of high. So let's take an example here of €5,000 invested at 4% AER. And they said if the interest is added monthly, find the future value of the investment after 3.5 years or 5 years and 2 months. So now what I'm going to do first off is try and understand, well, what is this monthly rate? So the formula I use is similar to the one that we had for the bonds, and it's P bracket 1 plus I to the power of T. And we can use this to say, well, if I invest some amount of money at 4%, so 0.04, for 1 year, that's the same as investing the same amount at another rate. I use OR for this rate, and this will be a monthly rate, so it'll be for 12 months, and that should be equivalent. And when we do that, the P's cancel. So we end up with a little piece like this. That is, I'll actually change color. So you have it. It will be 1 plus I is the same as 1 plus OR to the power of 12. And in my notation, I is your AEOR or APOR, depending, are we savings or are we in a loan? And in this case, we're saving, so it's AEOR. And then OR would be a monthly rate. Now, I'm saying monthly, but that could also be a weekly rate. And if it was weekly, it'd be to the power of 52. It could be daily, 365, and so on. So now we're going to work with that. We have 1 plus 0.04 should give me the same as 1 plus this monthly rate to the power of 12. That is 1.04 is equal to 1 plus OR to the power of 12. I'm going to flip this. So 1 plus OR is the same as the 12th root of 1.04. I'm so lazy when it comes to decimals and I get them wrong so much that I'm going to leave the root here and then subtract 1, which should give us our answer straight away in the calculator. So we're going to put in that 12th root of 1.04, take away our 1, and we get 0.00327,374, and then to put it, remember, into percentage, you multiply by 100, and that gives us 0.327%, and that is the monthly rate, and it's very small. Okay, and this is where it all gets a bit confusing and students get confused about, is it in decimal form, is it in percentage form? The easiest way around that confusion is to make sure that you write it in decimal form, and anytime then you convert to percentage and you use your percentage sign. So now that we have that rate, we can get into the actual question that they've asked. So they've asked us about 3.5 years, and what we're going to do is we're going to convert that to months. So that is 3.5 months, sorry, 3.5 years, which you 3 years, and then, yeah, so that is 42 months. So now we're going to get that future value. We're going to use F is equal to P bracket 1 plus, the formula is I to the power of T, but we're going to use this OR rate. So we get the future value is equal to 5,000 invested at 1 plus 0.00327, because remember it has to be in decimal form, and it's going to be for 42 months. That can go into the calculator. Remembering that this is money, rounding it to 2 decimal places unless we're told otherwise, and that works out as 81. So that's our future value. So part 2 is 5 years and 2 months, and that is 62 months. And we have F is equal to 5,000 times 1 plus 0.00327 to the power of 62. Again, that can go into your calculator. And 2 decimal places, 6,121.74. So that little bit of a conversion between the annual effective or annual percentage rate, depending on loans or depending on if it's a loan or savings, that tends to be a piece of a question itself, and then you may have to use it. We rarely see it mixed in the real exams, in the State Examination Commission exams, but we do see it mixed in some of the mock questions. So now we're going to look at a second formula, which is the present value formula. So this is a version of the compound interest formula. If you take a look at the formula above it, you'll see that this is just it rearranged. So P is equal to F over 1 plus I to the power of T. So if you wanted, you could use the compound interest formula and work backwards, but they have given us this present value formula. So you get a nice little kind of summary, in the sense that if I want the future value, if I want the future, I multiply. If I want to work backwards and get the past, I end up with that division, that fraction. So let's take an example. The local GAA club runs a draw, and if you win first prize, you are offered 15,000 now or 18,000 in 4 years' time. Which prize should you choose? Assume a discount rate of 4%. So that discount rate is explained up here. When calculating present value, the rate is often referred to as a discount rate, but it's still just really an interest rate. We can work this in two ways. We can either bring that 15,000 forward to understand the future value of it, but because we want to really work with our new present value formula, I'm going to take the 18,000 in 4 years' time and try to work out the present value of it. So the present value is the future value divided by 1 plus I to the power of T. So the F is 18,000. I is 4%, and that is 0.04, and T is 4 years' time. So the present value is 18,000 divided by 1 plus 0.04 to the power of 4, and that can go into your calculator. Remember, this is money, 2 decimal places, 15,386.48. So this has a higher value now, it's a higher present value than the 15,000. So which value should you choose to have the greatest amount? And that is B, the 18,000. So how many years would 5,000 increase in value to 6,500, so 6,500 if invested at an AER of 3.5%? So here I'm going to use the future value formula. It actually doesn't matter which one you use. Remember, it's the same formula, it's just been rearranged. The reason I've chosen to use this one rather than the fraction is because we don't have a fraction. Simple as that, but both would work. This is what we currently have. This is the F. I is 3.5%, which turns to 0.035. So we have 6,500 is equal to 5,000 times 1 plus 0.035, and we want to work out that value of T. So this is going to work backwards. It's using our logs, but before we do that, we're going to divide both sides by the 5,000 to keep that bracket on its own. 2, 3. And this ends up as 1.3 is equal to 1.035 to the power of T. Now, if you prefer, you can flip it around, and we're going to use log, so we're going to convert it. If you're converting using the circle method, 1, 2, 3, that means we have log to base 1.035 of 1.3 is equal to T. So we can get our value of T by putting this into the calculator. So log 0.035, 1.3, and that works out 7.627 when we rounded. In how many years would this have happened? So this doesn't round to a nice number, so we'll leave it at that.